PNDA, an open source platform for network data analytics. We're all told how much information is flowing around in the world, and those numbers keep increasing year over year. As we see more and more sensors streaming more and more data, and the amount of data rising by these numbers, the question is, what can we actually see? What are the insights that we can actually get from the data? When we start to bring the network as a data source and apply big data analytics to it, what are the questions that we can start to ask? PNDA is an open source project under the Linux Foundation, providing you with an ability to deploy an analytics platform built from best-of-breed open source packages. It can be integrated into your environment, ingesting a wide range of different data sources, and present those data sources to bespoke applications or off-the-shelf applications. A typical development lifecycle, starting from a Jupyter notebook and then working through to deployment of an application on top of the standard PNDA cluster, is a normal way for getting an application working. And we already have a number of partners who are working with us. Let's take a look at network data analytics in action. In this application, we're going to apply big data analytics to BGP using the OpenBMP project in combination with PNDA. In this view, we're gathering statistics from our BGP peers and understanding the number of prefixes that we're receiving, the numbers that are being transited, and the numbers that are being originated. The simple float over just gives us more information about who the individual AS numbers actually are. But we also have an ability to look at the fluctuations that are occurring. So we're actually counting the changes that we see in the BGP paths to understand the relative stability. Our recording capability enables us to investigate particular ASs to understand the prefixes that they originate or appear in the path of a particular prefix, and our visualization capability then allows us to show the connectivity between that target AS and its neighbors, showing not only the prefix that it originates, the number of prefixes that are transiting, but also the relative stability, plotting the more unstable neighbors further out towards the edge. In this view, we're now looking for a particular prefix using a wildcard search to show all of the paths that are being observed for this particular pattern. So here we can see a particular AS path, including an AS which is being padded. We're then able to sort that information, looking through using a range of different filters, including things like the path length to see the shortest to longest paths that are being observed. We also have the timestamps, so we are able to understand when these particular paths are being observed. I can further refine my search by putting a particular AS of interest into the filter, and then we're only presented with those paths where that AS is present. In this last view, we're able to look at the behavior of a particular prefix in a particular time period, using our analytics capabilities to observe its changes.